Welcome back to Introduction to Programming. This is video 10 in our series, and today we're going to talk about custom functions. My name is John Dwayne. So today it's custom functions. This is a very powerful tool in your programming toolbox, and you'll find many situations where you'll want to use this technique. One of the best places for custom functions is in worksheets themselves. They can take the place of those really long formulas that you are sometimes forced to place in a cell. The other use is in your programs, where you have a complex function, let's say maybe it's 20 lines of code, and you need this function several times in your program. If that complex function is in a function procedure, you can call that function with a single line of code, thus saving yourself the headache of writing that 20 lines of code over and over again. Plus, if you have to make changes to the function, you only have to change it in one place. Programmers refer to this concept as code reuse, and it's terrific. It's something you really should do. Okay, well, let's see what these functions are like. So let's put one on the screen. Let's get the interactive development environment. Here we go. So what you have on the screen there is a regular procedure. See, it begins with sub, it ends with end sub, empty space between the parentheses. Now let's take a look at a function. It looks different. Yeah, a function looks very different than a regular procedure. It starts with function. It ends with end function. It can take in arguments, so you see there's stuff in between the parentheses here. And it returns a value. Regular procedures don't explicitly return a value. They do work, but they don't return a value. Functions explicitly return a value. And because of that, we have to give the function a data type. So that's what you see here. This as string is the data type that this function has been assigned. Back to arguments for a minute. So inside the parentheses is the argument. Here we have one argument, but you can have as many as you like. Best practice is to identify the argument's data type. So here we have the as string. The by val keyword here that indicates that the program is passing a copy of a value to the function. Now we'll talk more about this concept in future videos, but for now we'll always use by val arguments. So arguments are how functions receive data to work on. So the data comes into the function via the argument or arguments, and the result of the work done by the function goes out via the return value. The return values statements begin with the name of the function. You see them here. And then the return value is assigned to the function with the equal sign. So by themselves, functions don't do anything. They have to be called by a program, a running program, and then used inside that program. So we'll call this function with this little program. Let me copy that into the code editor. And here we go. Okay, so this function, which uses some string functions we covered in video 9, changes the string to either uppercase or lowercase, depending on whether the first letter is a capital A. So right there. We break out the first letter for examination by using the left function and requesting just one character. So here you see left, string value, that's what we're going to be looking at. That's the big string, and then we just want one character. So if that's A, it does this. If it's not, it does this. So let's run it. And we'll run it with this program down here, show result. So enter a string longer than 3 characters. Okay. and okay, and there we go. So it's lowercase because that first letter was a small a. So let's try it with a capital A. And we get, there you go, uppercase because we had a capital A. Very good. Now let's look at another example. Just a second, here it is. And we'll copy this in. Let's put it up here. Give it some space. Okay, so here we've got another function that uses string values, string functions that is. It returns the middle three characters in the string passed in as the argument. It uses the len function, len, to figure out how long the string is and to calculate the midpoint. It uses integer division, remember that from video 8, to actually calculate the midpoint. It also uses the mid function to get the substring in the middle of the big string. So that's what's going on with that one. Now we have two procedures here, both say sub result, show result, and we can only have one of those, so we're going to get rid of this guy here. We'll delete that. So that'll save us from a compile error. All right, so let's run this one. So string longer than 3 characters. And there we go, HJK. Terrific. Okay, our final example, we'll go to module 1 for this, works with numeric values. It has one function that finds the root of a number, that's this one here. So that finds the root of a number, and another function down below that determines whether the root is perfect. So that's this function. For our purposes, a perfect root is a root that is a round number. Notice that the function finding the root takes two arguments, both integers, and returns a double value. If the number is 0 or positive, it will calculate the root by raising the number to 1 over the root. So the square root would be the number raised to the power of 1 over 2. The isPerfect function takes a double and returns a Boolean value, true or false. The return value all depends on whether the value passed in as the argument is a round number. So we figure that out by subtracting from the argument the integer stem of the number. That's what the int function here does. It is a built-in function that returns the integer from any number. So let's say the number was 1.5, this function would return 1. Alright, so let's run this. And we'll run it with this show answer procedure. So this is a regular procedure. And it's going to be asking us for some values. So we'll run it. Here we go. So enter the value. So I'm going to say 9, and the desired root, we'll take 2, the square root. And there we go. Square root of 9 is 3, and that's a perfect root because it's a round number. Very good. So let's change gears for a minute. You can also use these functions in your worksheets. Once you've written the function in the interactive development environment, you can call it in a worksheet cell simply by typing the equal sign and then typing the function name. So let's do some of that. All right. So here on this worksheet, I have some string values typed into column A. Well, let's use one of our new functions, and we'll do the change case, or change string. I believe that's what it's called. And see, Excel knows that that function exists, so it prompts me with the full name. And now inside the parentheses, I type the cell reference, so I'll click over there. And there we go. So that's what we expected to be returned. Let's copy this down and see what the values are for the other string values. And there you go. So anything with a capital A at the beginning is going to give us the uppercase. And we got that with Alabama here. So that worked. Let's try our other function. That was middle 3, right? And there it goes. It's prompting me for it. Middle 3. I'll put that cell reference there. So middle 3 doesn't really do much unless you've got 3 or more. And there we go. So the middle 3 of 3 is the ASD. And then it really kicks in here. And that works. The middle 3 of New York, the first character is a space. So that all makes sense. Let's go over to our numeric example. So over here, I've already typed in the find root function. Let me copy it down and see what the find root function does for all these other values. Oh, there they go. I'm finding the second root of all these numbers, so basically the square root of 4 is 2, square root of 9 is 3, 16 is 4. Those are perfect roots. Let's take cube roots. Let's see what happens there. And they all adjust. Interesting. Let's do our isPerfect function. We'll put that over here in the notes. I've got a longer formula that uses it, so I'll paste that in. And put that there. So you can see up here, I'm using the isPerfect function inside a regular formula, regular if formula. So if isPerfect B6 over here is true, then I get perfect root, otherwise not perfect root. So let's copy that down. See if that works. Oh, there we go. And if we change this to 2, these all adjust. So that's a great example, I think, of how you can use your custom functions inside a worksheet as the functional by itself or as part of a larger formula. Well, I hope you enjoyed this. I hope you found it useful. If so, please subscribe to this video series, write comments, and I hope to see you next time.